that tomorrow you need to give me the corrections for the quizzes. Okay, is the quiz and staple the correction. Not in the same quiz, please. Have to be in a different. Yeah. Sorry about the trees and everything, but have to be in a different place. Okay. If you want the curve, if you don't want the curve, then don't do anything. But the correction is going to count an activity also. So even if you don't get the curve, it's an activity. So it's going to count as touch. Okay? So don't forget that. Also don't forget that project. The project is going to be due next Monday at night. It's just the cover page, and you can do everything. You can solve the problem by hand if you want to. Solve the problem by hand, but it has to be scanned in a PDF document. Okay?
Are we going to upload it or?
And you want to upload it to the social media. Okay, fine, ready? Okay, as I told you yesterday, we're going to see one technique per day. So today is the second one, tomorrow another one, Thursday and Friday another one. So we covered the whole week with the 5 things of integration. Also, I was thinking, well, last group that explained this topic, let's say that they didn't get a lot. So I was planning to give one more day to practice both techniques, the one from yesterday and one from today. Perhaps with you too. I just want to see how you react to the examples, okay? If you react well, then we continue. If not, I'll give you one more day to practice both. But it depends, because you're a good group. So I expect that you do well with this. Okay, you remember yesterday for the substitution. Substitution was the technique used to apply the inverse of the channel, right? Of the channel and derivatives. Now for integration by parts, this is used for integrals that cannot be done by substitution, and this one is going to be the inverse of the product rule. Okay? Because there's no product rule for integrals, but this is the inverse for that. So we're going to use this technique when you have, for example, like the first one, a product of functions, but the derivative of one is not there. For example, in this case you have x e to the x. If you were to say u is x, the derivative is not x. So it's not a substitution. For this one, for example, ln of x and you have x squared, the derivative is not there. So you cannot just multiply by x, that's not possible. So for those two examples, we need to use this technique. It's called by parts. Now, I could give you the formula and that's it, but I want to demonstrate how to get it from the product rule. In this case, assuming that f of x, we're going to call it u, and g of x is called b, to make it simpler. You remember the product rule, the derivative of product was the first one times the derivative of the second, plus the derivative of the first times the second. Remember that from last semester? Yes. Yeah. Now, that's a product rule. Assuming that I want to change this into differential form, remember, I need to put a dx, which is dividing, multiplying each term in the other side. So this one is going to be d of ub, which is the differential, equal to u times b prime dx plus u prime b dx. I just multiply. Yeah? And b prime dx becomes db, the differential of the variable b, or the function b. And u prime dx becomes the du, the differential of the function u. Do you understand why? Yeah? Okay. So, in this case, for example, in this form, we're going to integrate. So, if we integrate, for example, this side and that side, the interval for this differential, well, it becomes the original one, which is u times v. And the integral for this part plus the integral for that one is this one and that. Okay? And in this case, I'm going to isolate this part. So now I have the integral of u dv equal to u times v minus the integral of v du. That's the formula. Now, what's the objective of this formula then? The idea is to match this integral that I have into this form. So I can apply the formula to solve it. Because this integral is going to be something simpler, something that you can solve directly. Okay, so just like yesterday, the idea is to rewrite, to match this one into this one, so I can apply the formula. Okay? We'll do an example. Check this one, number one. You have integral of x times e to the x dx. The idea, as I said, is to match. Represent the u and represent the v. Divide the factors of the integral. So for example, in this case, I decide that my factor u is one part of the integral. But which part? X. And dv is going to be the other factor of the integral, which is e to the x dx. So we already have both factors for the original integral. Now, once you have that, we're going to get the formula. But in the formula, you observe we need u, we need v, we need v, we need du. We only have u and dv. What do I do? Get the other ones. If this is u equal to x, du is going to be what?
X dx.
1 dx. The derivative of x is 1. For this one, v, the integral, e to the x. No need to put c in here. C will be at the end. Okay. Now I have u, dv, du, and v. What do I do now? Apply the formula. So now my formula is going to be u times v, x e to the x, minus integral of v times du, v times du, e to the x times dx.
Wait, but why is b e to the x?
Because of the integral of this one. In this one, for example, from this side to that side, I need to differentiate. And in this case, I need to integrate it. Mentally, of course. Can I solve this small integral? Yeah. So my final solution is going to be x e to the x minus integral of e to the x, e to the x plus c. That's the solution. And that's it.
Pero tú no sabes cuál es L y cuál es D.
Going into that. Going into that. Okay, so the question, yeah. How can I tell which one is going to be my u, which one is going to be dv? Usually dv, this one, has to be the complicated factor of the integral, okay? Whose integral can be obtained quickly. And the u is going to be the factor whose derivative is something simpler, okay? For example, in this case, u, the derivative is just 1, which is simpler. And in this case, e to the x, well, that's the complicated part, but the integral for that is not complicated to get, right? Let's try the second one, and then I'll use the rules. I have u, and I want to get also dv. Think a little. Which one? First, I have two factors. One of them is x squared, the other one is ln of x, and dx belongs to one of them. Which one will be the u, and which one will be dv? What do you think? Think a little more. If you say that u is x squared, the derivative is going to be simpler. Yeah, that's okay. But dv will be ln of x. The problem is that when I integrate ln of x, can I do that directly? No. No. There's a formula, a complicated formula, which I gave at the beginning. But the idea is not to use that. So instead, what I'm going to do is I'm going to put ln of x as my u. And dv is going to be x squared. Now there is the complicated part, okay? Let's see what happens. If I do that, in this case, what is du? What's the differential of ln of x?
1 over x.
1 over x dx. Don't forget the dx. And for dv, b is going to be x to the cube over 3. Okay? Again, you will say, no, this is more complicated. Okay, well, let's apply the formula. If I apply that formula, u times v, x to the cube, ln of x over 3, minus integral of what? b times u. So, 1 over x times x to the cube over 3 dx. Right? Question. Can I simplify this and then solve it? Yeah. X to the cube ln of x over 3 minus integral of 1 over x times x to the cube x squared over 3 dx. Can I solve that? Yeah. Minus done. So even though the guideline is that the dv has to be the complicated part, well, you need to be careful because also it has to be a function whose integral can be done directly. So that's why you didn't choose ln for the dv. Do you understand that? Okay.
Mister, so you already have the number and you integrate, you multiply the number.
Oh yeah, of course. That's a coefficient, so it's like 1/3. The integral for x squared, x to the cube over 3. So you multiply. Okay, let's try an example from the activity. All the activity. By the way, all activities, the one from yesterday, the one from today, the one from tomorrow, etc., are going to be due next Wednesday. Not tomorrow, next week. So we have a whole weekend to finish that. Okay. Can I read this? By the way, there's a little, well, let's say game or technique to memorize the formula a little better. We don't like it because it's like just a child's play, something like that. But I'll give you still, so you have it, if you want to. ¿Se acuerdan de Mate 4 cuando veíamos el Socatoa y el Cotocaca y todo ese rollo?
Sí.
Algo parecido. Entonces, como estoy seguro que no se van a aprender toda la demostración, no se los voy a preguntar. Debería, pero no lo haría. Hay una técnica para aprender esta fórmula más fácil. Se le llama la técnica del soldadito. Un valiente soldadito vestido de uniforme. No me sale el menos, pues. Un valiente soldadito vestido de uniforme. Esa la pueden aprender.
¿Por qué no le gusta todo?
Porque es para niños. ¿En serio?
Yo también tengo 17, profe.
Saltado con la mano al antro, ¿verdad? Sí, todos son niños. Fine.
De abril.
Anyway.
10 de abril.
Let's try the first one. T-squared cosine of TDT. Observe, is this one by substitution, the previous topic?
No.
No, because the derivative is not there. How could be an integral that could be done with substitution similar to this one? La pregunta la repito. O sea, ¿cómo sería una integral que se pareciera a esta, pero que sí sería por sustitución? ¿Qué tendría que tener, por ejemplo? Que fuera por sustitución, como lo de ayer. ¿Eh? ¿De qué? Ok, ahí les va. Yo lo estoy diciendo para que ustedes vayan siguiendo una de otra. O sea, esta no se puede porque tengo t y t cuadrada. Agarrar a t como u, su derivada no es t cuadrada y no puedo multiplicar por t, definitivamente. Pero, si por ejemplo la integral fuera así, t cuadrada coseno de t cúbica, por ejemplo, ¿sería por partes o por sustitución? Pues,
Por partes,
a ver,
¿no?
si yo agarro mi u como t cúbica, la derivada de t cúbica está ahí. No completamente, pero exactamente, o sea, le falta un coeficiente, 3, se lo puedo multiplicar. Aquí ya hicimos uno parecido, ¿no? Ok, entonces, ¿qué diferencia tiene esta? Esta no está su derivada, esta sí está su derivada. Más falta modificar el coeficiente.
¿Pero cómo lo harías?
¿Cómo se hace ayer? O sea, agarro lo que es u, saco de u, cambio la variable. A diferencia de esta, que es como lo vimos ahorita. Anyway. Okay, in this one, for example, which one is going to be my u and dv? What do you think? U is cosine? No, don't think so.
¿De qué depende? O sea, para qué?
T, ¿no? T es el U. No.
Now,
Sí, no.
try to think ahead. Beyond and everything. If I were to put cosine here, and here t squared, okay, fine. What's the integral of t squared?
3 sobre 3.
U over 3. Its derivative of cosine? Minus sine. So you still have t to the cube times sine inside the integral. You need to do it again and again, and it's going to be more and more and more and more complicated because the integral keeps getting bigger and bigger and bigger. Why not in that one? Because in that one it's simplified. ¿Sí lo ven o como que les hablo en chino? A ver. Bueno, no, la más saben, ¿no? Supongo. O sea, no se lo voy a escribir, quiero que se lo vean, quiero que ustedes lo vean, si va a ser en el examen, no van a escribir tanto, si no se van a acabar el tiempo. Váyanlo viendo, otra vez. Vean cómo está la fórmula y vean todo lo que hice aquí. Aquí, por ejemplo, hice esto y luego tengo que multiplicar b por du para meterlo en una integral y simplifiqué, ¿están de acuerdo? Ok, ahora imagínense aquí. Imagínense el du y el b. Si yo pongo t cuadrada en la db, t cuadrada y la integro, ¿qué me queda? T cúbica. T cúbica. ¿De arriba qué me queda? Seno. Menos seno, pues. Seno, pues. La integral sería ahora t cúbica por seno, según la fórmula. ¿Están de acuerdo? Ok. Si lo volví, ya me quedó algo más grande. Ahora es t cúbica por seno. Si lo volviera a integrar, tendrá que volverlo a integrar esa parte, otra vez por partes. Otra vez t cúbica, se vuelve t cuarta. Por coseno, que sigue ciclando en coseno. Casi no cada vez más grande. ¿Voy a resolver eso? Jamás. No va a poder. ¿Sí? Entonces quiero que lo visualicen. Si hay otra técnica, si hay otro truquito para decirles qué hacer y qué agarrar siempre, pero bueno, o sea, se los voy a dar. Pero quiero que ustedes también lo sepan visualizar, o visualicen, ¿sí? Porque no siempre van a poder. El truco es este. ¿Ah? El truco es este. Otra técnica. Sí. L es por logaritmos o LN. Ahorita voy a decirles, este es para inversas. ¿Qué tipo? Arcsine, arccosine, arctangent. Algebraicas. Trigonométricas. Exponenciales. ¿De qué me sirve eso? Me está diciendo la prioridad para agarrar las U. ¿Sí? ¿A qué me refiero con eso? What's the meaning of this? It means that in your integral, observe what you have. Depending on what you have is your U directly. So if your integral has an ln, that's your U. If your integral has an algebraic and exponential, the algebraic is a U according to the priority. L, I, A, D, E. In this one, I have an algebraic and a trigonometric. Which one will you might use according to the priority? Algebraic. So T squared. Okay, so it depends on what you have. Is a priority for the U. Okay. So this is the other one, which is cosine. Do you understand that?
Yes.
But still, observe. Observe. Okay, integrals in this case, unlike derivatives, integrals are a little more complicated. Observe.
Luego, si lo haces al revés, ¿en qué punto se tendría? O sea, sí, será infinito, ¿no? Por la división.
The degrees are going to get getting bigger. So they can stop. Du is going to be what?
2, 3, root t.
And b is going to be what? Sin of t. Okay, so what apply the formula? We're going to call the integral I, the solution. So it's going to be u times b, t squared sin of t minus integral of b du to t sin of t dt. Yeah? I just apply the formula. No, the integral of cosine is Now the question is, can I solve this integral directly? No. No. What do I do? Again. But the degrees are getting lower. So we're going to finish eventually. So, for this part, again, u dv. Which one is u according to the rule? 2t. And dv, sin of t dt. du is going to be 2 dt, and b is going to be
Minus cosine.
minus sine, cosine, sorry, yeah, you're right, minus cosine of t. So, integral of everything, t squared, sine of t, minus, parentheses, the solution of this with my formula. U times b minus 2t cosine of t minus integral of minus 2 cosine of t dt. And just apply the formula in the parentheses. The same formula, but for the new concepts, the new elements. Can I solve this integral now? Yes. t squared sine of t minus minus plus 2t cosine of t minus times minus plus times minus minus integral of 2 cosine to sine of t plus c. That's my answer. Yeah? Yes. Which one? From here? With the formula? Remember, I cannot do that directly, so I need to apply the formula again. I found u, which is 2t. I found dv, which is sine of t. So when I apply the formula, which is u times v is this one. Sorry, this one. U times v, this one. This is what the one that I had at the beginning. But this part of the parenthesis is the solution of this part. And then I need to solve this integral directly, which is the last term before the second. Okay? Questions?
Profe, ¿cómo sabes hasta, o sea, cuándo ya no puedes resolver?
That's up to you. Is there an integral for cosine? Directly? Yeah. Not for this one, but you have t sine of t. Remember, there is no product rule for integrals in the game. But when you have only the cosine, there is a rule for that, which I did. Sine of t. Okay, so when you need to observe. Any more questions?
Sí, profe, yo sigo sin entender cómo que vaya de atrás. Ah, ya entendí.
Yeah. So, in this case, we apply the formula twice. What will happen if this was t to the q, for example? If it was t to the 5th power, then. We don't know, perhaps. Now, listen. There is a way. There is a way to simplify the process if you have integrals such as this one. Not all integration by parts, but such as this one. There's a way to simplify the process instead of doing 1, 2, 3, 4 times. So I'll give you that. Depende de calcular.
¿Sabes que por ejemplo, cuando vimos.
Ya, sí, no está.
¿Qué era? El tercero como lo que ponen en los exámenes, de que la desviación está bien.
That's the numbers.
Pero no hay una técnica así de que se puede usar.
But we're not solving numbers here, not right now. But if you have a calculator or a graphic calculator, then well, they do this, but they're very expensive.
¿Qué dice?
E to the AX. Okay, listen. If, for example, your integral has these three types of forms, polynomial, not just any polynomial, polynomial times an exponential, polynomial times trigonometric sine or cosine, there is a way to simplify the process. Okay, instead of applying the formula 1, 2, 3, 4 times, there's a way to simplify the process, which is called the tabular method. This process is not one that the teachers in professional like, but well, I don't care. So you can use it if you want. So I want to simplify the process. In this case, it's very simple. The idea is that you want to make a table. In this table, you're going to choose your U and your dV as columns. But the U is going to be the polynomial part. And dV is going to be either the exponential trigonometric part. So e to the ax or sine of ax or the other one, the cosine of ax. Okay? Now, what you're going to do is this. You're going to start differentiating this, until you obtain 0. Until you obtain 0. And you're going to start integrating the other column until you obtain the same level as with the 0. That is, derivative until you obtain 0, and you're going to start integrate until you have the same level as with the 0. Okay? And for each solution, let's say that you have solution, derivative, integral. You're going to multiply this first one times this first integral. Then this one times this one, then this one times this one, and this one times the last one, for example. And before each one of those will be a sign, positive, negative, and the zeros are coming. So it will be, for example, plus this times this, you put it, minus this times this, and you put it, plus something, plus this times this, plus something else, and you go on, and that's the solution. That was the solution. Okay? Let's do an example so you get the idea. It's not complicated, but it allows you to get these kind of integrals faster. Yeah.
Ahora you're gonna multiply the last one by the U.
Los de mate financiera quejándose.
This one
Ya
and the
sé.
last one.
Marcan al mismo nivel.
No, that's why. It's not this one and this one. No, it's this one times the second level.
Ajá.
Then this one, then this one, and this one, and the last one.
Pero en la penúltima se va a acabar la última.
But there will be something there. But there will be something here.
O sea, la última de U se va a quedar sin nada.
Yeah. You'll see. Okay. Let's try this one. For example, the same example, this one. But using this method, see what happens. You have this one, has the same shape as that, polynomial, trigonometric. So, for example, I need a U and dV. Which one would be my U? T squared. dV. Cosine. So, start differentiating. Derivative.
T,
Derivative.
2,
Derivative.
0.
Integral. Okay, now, before this one will be plus, minus, and you multiply as this one. So, t squared times sine. Minus 2t times minus cosine. 2 times minus sine. What you consider that, so this minus times minus becomes plus. So this tabular method simplifies this process for these kind of integrals. That's why I'm teaching you that. No, jamás. Nunca le he dicho que si ahí les va esto, pero no lo hagan. Yo no sé si es un maestro, pero yo no. Generalmente los maestros de profesión no les gusta esto, se les hace también como un tipo jueguito, pero la verdad tiene su razón de ser. O sea, estamos siguiendo un patrón de valores, no tiene nada de malo. No está dando un truquillo para acabar rápido. Tiene un patrón, estamos siguiendo un patrón, algo que es muy lógico en matemáticas, seguir patrones. ¿Sí? Pues si no llegan a profesionales, es que no veo esto, eso. Pues entonces llegan a mí me enseñaron que tiene un patrón y vamos a hacerlo así.
¿Dónde?
Y el maestro estaba le pregunta. ¿Sabes qué más tienes patrones? Cero.
Okay, fine.
Alan.
Questions? Okay. Yeah.
Mister, pero solo aplica cuando tiene una...
This is that. If it has a logarithmic function or something, then no, we need to apply the whole formula. Before I end the class, I'm going to do one more, but this one is going to be, yeah,
Ah,
a little more complicated. Can I write this?
yes.
Yes. Ya, decidí que mejor si las de mañana para repasar las dos cosas, ¿sale? Mejor mañana hagamos un día para repasar las dos técnicas para que les quede claro perfectamente.
¿Cuántos son por decirte?
5
que
Técnicas.
técnicas. Pensé que
técnicas.
integrales acá.
No, las técnicas. Okay. Last one, and with that we finish. E to them, 2x and 3x. E to x sine of 3x. Yes. Okay, fine. This one, for example, could this one be done with tabular method? No. You could, but only after you see what happens. Okay, so we're going to do it directly with the formula, and then you'll see what to do, because it's not directly. This one is not a polynomial, it's an exponential and trigonometric, so it's not as this one. So in this one, for example, just like we did at the beginning, we need to choose u and dv. U and dv, which one will be your u? Yeah, sine. In this one has a particularity that it doesn't really matter, because you have exponential and trigonometric, and both are basically the same priority. But fine, follow the rules. So dv is going to be e to the 2x dx. Derivative. 3 cosine of 3x dx. Sorry, du and b.
E to the 2x.
Again.
No, 2e 2x, ¿no?
Es la derivada.
Ah, la derivada. Ah. Pues sí dijiste 2x, ¿no? Ah.
Why? Because if chain rule is multiplying, integral divide. It's substitution, basically. Quite simple. Okay, so
Madre mía.
I'm going to call this one I. So I is going to be u times b. E to the 2x sine of 3x over 2 minus integral of e du, which is 3 halves e to the 2x cosine of 3x dx. Agree? ¿Eso cuál es la fórmula? Observe. Can I integrate this directly? No. But what is happening? It starts cycling. Again and again and again. So, let's see what happens. Yeah, we'll do it. I'm going to choose this integral, and I'm going to do it again. U and dv. U is going to be cosine. Now, du, the differential, is going to be minus 3 sine of 3x dx. Do you agree? Yeah. E to the 2x dx in the integral will be e to the 2x over 2. Yeah? Yeah. Okay. We're going to call this integral I1. Just because. Okay? So I1 is going to be, according to my integral, my formula, u times b, e to the 2x cosine of 3x over 2. Yeah? Minus the integral of b times du. Since you have minus 3 and you have 2, then times minus becomes plus 3 halves integral of e to the 2x sine of 3x. Do you agree or are you lost? Lo único que hice fue aplicar la fórmula y de una vez ya mentalmente, ahora tener que es entre 2 y tener menos 3 es menos 3 medios, ¿están de acuerdo? Menos 3 medios por el menos de la fórmula se vuelve más 3 medios. ¿Estamos de acuerdo? Ok. Can I erase? What happens there? What is happening there? Yeah. So, what happens is going to start repeating itself again and again and again and again. But let's put the entire solution so far. E to the 2x sine of 3x over 2 minus 3 halves I1, which is the total solution, which is e to the 2x cosine of 3x over 2 plus 3 halves integral of e to the 2x sine of 3x dx. Yeah? I just put this instead of the integral. Yeah? Yes.
Si nos aparece en el examen, ¿se lo puedo poner como 3 halves of I1?
Yeah. You may. Okay. Yes? We're going to get rid of the parentheses. So, e to the 2x sine of 3x over 2 minus 3/4 e to the 2x cosine of 3x, yeah? Minus plus minus 9/4 integral of e to the 2x sine of 3x dx. Yeah? I just multiply. Yeah? Now what? Do I need to do it again? No. This integral is the same as the original one, which is I. So what I have now, I'm just putting every step. You can skip some steps. I'm just putting everything you can understand. E to the 2x sine of 3x over 2 minus 3/4 to 2x cosine of 3x minus 9/4 I. ¿Qué? ¿Ya se perdieron? No. It's an equation.
I to the
¿Ya? ¿Los ves? Yeah? Yeah? So it's, you divide everything or the reciprocal, so it's going to be 2e to the 2x sine of 3x over 13 minus 3 over 13 e to the 2x cosine of 3x plus c. That's my solution.
Profesor, ¿la verdad estás en el examen?
What do you think?
Sí.
Me ahorra el paso, nomás el lado de dividir coeficientes, pero pues es pura aritmética. Estoy dividiendo entre 13 cuartos, aplico los recíprocos para cada uno y ya simplifiqué mentalmente. Pero pues, eso ya es obvio. Entonces, mañana hacer un repaso de los dos técnicos, ¿sale? Nos tienen la actividad la anterior y la de hoy para hacer varios ejercicios de la actividad, ¿sale? How many days is tomorrow?